Today we will present georeferencing. So it is a very important tool, important process that we must know before we do digitizing, because in real world there are many types of maps which are all still in hand drawn and not yet digitized. So we have to digitize the map to get a better picture of spatial relationship among the maps. And there are, to be honest, 90% of the maps of current world is still hand drawn, like the very much detailed maps of any jila or upazila, which is called municipality. So now we use georeferencing to assign the real world, the digitized version of these hand drawn maps. So let's see what it is. So what is georeferencing? Before going through all the details, just look in this picture. So here we see this is a hand-drawn map of an Mauja of Bangladesh. So it's the community detailed map. If each community details ownership of single person, so like thousands of maps like this are still hand-drawn. So we have to assign them to the software to know where it is from and digitize it. So we'll just focus on what is the details of georeferencing. So georeferencing basically is the process of aligning a digital image, such like scanned map, aerial photo, satellite scenes, to a geographic coordinate system by identifying ground control points that link pixel location to known real-world coordinates. So when it is used, scanning and digitizing old paper maps, aligning historical imagery with modern base maps, integrating photos lacking spatial metadata, correcting satellite imagery with positional drift. And here are some key concepts. So first of all, we need GCP. So in my picture I can identify GCPs, like this one are post we have added because we know the locations of these places. So these are the GCPs, ground control points. So I have like these ones in this map. And then transformation, so mathematical model fitting GCPs to coordinates, RMS error, residual error between actual and estimated GCP position, then resampling and spatial reference. And what are the process? We will actually see practically what are the process later, but let's just now recall it. So first of all, load raster, add the GCPs, check RMS, transform, resample and save. So these are the transformation types, but we will always use most of the time polynomial fast affine, because only 3 GCPs are required for this, and we will later use polynomial second degree, polynomial third, spline and projective. So resampling method, we also use resampling. The most commonly used what we now are bilinear and cubic transformation, because nearest neighbor is just old and doesn't provide actual values, the correct ones. So we will try to maintain these practices, like spread GCPs evenly across the entire image, avoid clustering in one area, aim for RMS 0 less than 1 pixel, and use high accuracy base map, always save output as a NIF file. So now we will go to our software. I have some, before opening ArcMap, I have something to do first. I will go to my folder where I have stored my data and go there, and I have actually JPEG data of, these are the image files actually, and I have database file which are actually the coordinates. First of all, I have to, currently the ground control points are in DBF format. I have to convert them to XLS first before opening to ArcGIS, because this is the correct opportunity how we can get. So first of all, I am gonna go where I am gonna go Excel and check for a new blank, and I am gonna open the file that I am gonna desire to open now. I am gonna go research project, no, actually big data. this is the folder, and I am gonna open a dbf file in, and I'm gonna go with Bara Barait S7. Okay, so I'm gonna just click it open. So right now I can see the x coordinate and y coordinates. These are the ground control points, and now currently it is in dbf format. First, now I have to change it to standard numerical values. So I'm gonna copy it, open a new sheet and paste it here, and during pasting I'm gonna select numerical values, and now I'm gonna select it and give it a name like Barait S7, just for easier purposes. Now if I just click here and select Barait 7, it will just be pasted. This is how easy it is. I'm gonna just click it again and assign the name is Barait SS7 and click on enter. Now it is just stored using like this. So now I'm gonna go to ArcMap and open a file which one we just got the GCPs for, and go to catalog, go to here. I'm gonna go to ArcMap and go to catalog, open the files. How do you have just got the GCPs for? I'm gonna go to metadata and lab data, JPEG, and Barait S7. I know the name is pretty much confusing, but it is what it is. We got. So right now I can see these are the ground control points. We have just opened ArcMap for now. Now I'm gonna open the latest GCPs what we've got in. Okay, so I have to first save it actually. So I'm gonna just save as, I'm gonna go to the same file and save it as XLS, cause obviously workbook greater than 2003 is gonna not open in ArcMap. Just click it, save here. Okay, now if I just can see and refresh, and Barait S7 is here. I'm gonna open the what we have just created, a special name Barait SS7. Now I'm gonna right click it and open what are the coordinates and display XY data. I'm gonna define x coordinate and y coordinate and define the coordinate system. I know the coordinate system is BTM, so you have to actually choose what your recipes are from actually. Click on OK, and I'm gonna open zoom to layer. Here I've got, these are my points. Now actually I have to get this toolbar georeferencing. Now click on this map, and by clicking on georeferencing I am gonna select fit to display, so it will just get an overall objective value. Now I have some tools here, so I am gonna use the shift tool to just visually just match the coordinates first before applying any transformation or analysis. Just like change the color actually. Okay, so I am gonna approximately join them. I have some tools here I have shown you. Now I'm gonna use the scale to just little bit scale it down, little bit up, and then shift again and try to just join it. So let's scale it down a little bit. Okay, so now shift. Now I can see it is almost perfectly got, but now the real case we will now use manual transformation. So for that I am gonna click on this value and now I will select up to 4 control points to actually connect my GCPs with the real values. So for that, just click on the image itself, then click on the coordinates what I've got. If I just click it, it will automatically bring it closer. Now go to the endpoint and just select it. Okay, the first I have done is actually very much important because we have to know which values are which defined. So now after defining 2, almost it is perfect, but I will join more. Just 3. I am gonna add one more, this one. Okay, so click on this. Now I have added. Now if I open the contingency table, link table actually what is called, I can see my total RMS error is 0.34. So it is actually very much good. We have got the residual, the least residual was the second point I have got. No, yes, the second one was least, it is 0.26. Now if I want, I can save the table anywhere where I want. I'm gonna just go to downloads and I'm gonna just save it like this, and just click cancel, I don't care. Now the fun part, I have just completed my analysis, I mean georeferencing. Now I'm gonna click on here and update georeferencing. Now these values are assigned to the map itself. Now let's show you some magic. I am gonna just remove the image, and if I bring back the image again, it will automatically detect these control points. Let's see how. I'm gonna click here and open the file again as 7. Here we can see it is already georeferenced. So this is actually because if I open my source file, and I can see there are 2 additional files have generated. XML file by the name of the file I have just georeferenced it, and JGWX file. So these are actually the file which contains the metadata of georeferencing itself. So we don't have to define georeferencing again and again. So we can use like this forever. So I think this was it for the georeferencing. We will actually meet with some another new videos soon. Thank you very much for watching. Goodbye.